Hello everyone, this is the second grade enhanced math week 16 solution video. Problem 1. Put the right numbers in the blank. We have 400 plus something equals to 800, and since we know that 800 is just 400 times 2, right? So that's basically two 400s added together, 800. Next one, 2000 minus something equals to 1,000. We get that 2000 is just 1,000 plus 1,000. So therefore it's 1,000. And then the next one is 2,600 minus something equals to 2,000. We know that 2,600 is just 2,000 plus 600. And then we minus 600 right here. Next one, 850 plus something equals to 900. We just do 800, 900 equals to 850 plus 50. So therefore we put 50 here. Next one, 3,000 plus something equals to 3,200. It's obviously just 3,200 equals to 3,000 plus 200. So we add 200. And finally, 960 plus something equals to 1,000. 1,000 is just made up of 960 plus 40. Problem 2. Express the following numbers in digits. We know that let's make it up to 1,000. So 1,000 has 4 digits. And then the rightmost digit would be a units digit with only one number, followed by the tens, which encompasses the unit digit, followed by the hundreds, which encompasses both tens and units. So let me just draw it in green. So the tens is in green, while the hundreds is in blue. And finally, the thousands, which is in black. So it encompasses everything, 4 digits. Okay, and now let's see the first one, 346. We see here that immediately it says 300, so we put a 3 in the hundreds place, and 46. So 40, that means 10. So we put 4 in the tens place, and 6, which is one digit, we put in the units, 346. Next one, 803. We put 8 in the 100, since it says 800, and then 3. So we put a 3 in the units. Notice that this time it didn't say anything about the tens digit, so therefore we just put a 0 here. So 803. This time it's encompassing 1,000. So 1,470, how do we put that into digits? Well, it says here 1,000 first, so we put 1 in the thousands. 400, so we put a 4 in the 100, and 70. So 7 in the tens, 0 in the units. 1,470. And finally, the last one is 5,026. We write that out 5 in the thousands, and 26, 2 in the tens, 6 in the units, and 0 as a placeholder in the hundreds. So the final answer is 5,026. Problem 3. Number 1. What are the two adjacent numbers of 6,543? For this, adjacent means that the number is right next to 6,543, so either subtract 1 or add 1. In order to subtract 1, we always start from the rightmost side, the units. So therefore, 6,543 minus 1 from the units, 6,542. So we write 6,542, and then 6,543, which is the middle number. And then this time we need to add 1. So if we add 1, we get 6,544. So therefore it's 6,544, which is 1 greater. And then these are the two adjacent numbers of 6,543. The second part of this problem is what are the largest and least 4-digit numbers consisting of 2 4s and 2 zeros? Well, it's asking us for the least. So let me write the least. And the largest 4-digit numbers that have the choices of 2 4s and 2 zeros. Obviously, if we want the largest 4-digit number, we're going to have to put the 4s directly in the front because that's where the thousands digit and the hundreds place is. And those are larger, so therefore we need to put the largest numbers there. So I put the 2 4s in the front, obviously, and the zeros have nowhere else to go, so they're in the back. Sorry, let me put this as at the bottom since it's the largest. So 4,400 would be the largest. And then now let's see the least. Obviously, we cannot put 0 in the thousands place, otherwise that's not a real number. So therefore, we must start off with 4. However, that means that we can put the 0 in the hundreds place and the tens place. And finally, we put the 4 in the units place, which is the least. So therefore, these are the largest and least 4-digit numbers consisting of 2 4s and 2 zeros. Problem 4. Round the following 3-digit numbers to the nearest 3-digit numbers ending with 0. We start off with 354. As we see here, 354, we can either put it into 350 or the 360 slot, since 354 is greater than 350 but less than 360. For this problem, all we have to do is look at the last digit. Is 4 closer to 350 or is closer to 360? And the answer is 350. So therefore, we can put 350 here. The next one, 876. 876 is obviously greater than 870, but less than 880. So we look at 6 again. Is 6 closer to 870 or 880? And the answer is 880, because it's only 4 digits away from 880, whereas 870, it's 6 digits away. Therefore, it's 880. Next one, 603. 603 is greater than 600, but less than 610. We look at 3 again. Is 3 closer to 600 or 610? The answer is 600. Next one, 988. 988 can be split into 980 and 990. We look at A to see which one it is closer to, and obviously it's 990. This time, without even thinking, we can obviously just know which one it is. 421 is closer to 420 or 430, obviously 420, since it's only one number away. And finally, 599, again, it's only one number away from 600. Moving on, problem 5. How many digits are required to number the pages of a book having 100 pages? For this problem, we can split it into three parts. First, the 1-digit numbers, which is just 1 to 9. 1 to 9, added to the 2-digit numbers, which make up the most of the set. So this is anywhere from 10 to 99. And finally, page 100, that's basically just 100. So we automatically know that this is 3 digits. And then 1 to 9, that's very easy. That's just another 9 digits. But the middle one is where we really need to solve our thinking. In order to solve the number of digits from 10 to 99, we first need to solve how many numbers there are. So 10 to 99, we can solve this by subtracting 10 from 99. So 99 subtract 10, 89. But remember that we have to add back 1, because when we subtract both, and that basically erases one number from the sequence. So we need to add back a number, which is we need to add back the 10. In the beginning, that was canceled when we subtracted it. Therefore, this new number is 90. So there are actually 90 numbers between 10 and 99, not 89. So therefore, we do 90 times the 2 digits in each number equals to 180. So we can do 9 plus 3, which is just 12. And then finally, 180 plus 12 equals to 192. So there are 192 digits required to number the pages of a book having 100 pages. Problem 6. Using 4 digits, 1, 2, 3, and 4, it can form 24 different 4-digit numbers. Rank these 24 numbers from the least to the largest. What is the 20th number in the sequence? Well, we know that since 20 is very close to 24, we can just count backwards. So we can do 24th largest, 23rd largest, 22 largest, 21st largest, and finally 20th, which is what we're looking for. Let's start off with 24. Obviously, the 24th largest, which is the largest in the entire sequence, is just 4,321. The next one would be 4,312. The 22nd one would be 4,231. The 21st would be 4,213. And finally, the 20th would just be 4,132. So the answer is 4,132. That's the 20th number in the sequence. Problem 7. How many 3-digit positive integers have digits whose product equals 24? So right here, we know that since there are 3-digit positive integers, we know that for each one, we basically just need to multiply them together. So multiply. So basically, we need to multiply these 3-digit positive integers whose product equals to 24. So let's try out all different cases. Well, first, we obviously have to try out 1, right? 1 times 6, that's 6, right? And then 6, we see that 6 times 4 equals to 24. So that is a valid case. The second one, let's see if there's another one, which I'm sure there is. Let's see, 3 boxes for 3 numbers again. This time, let's do 1 again. And this time, we see that 1 times 8 equals to 8. But then 8 times 3 is also 24. So there you go. That's another possible outcome. And then the next one, let's see. Let's see the next one. This time, let's start off with 2. 2 times 2, which is 4. And then 4 times 6 equals to 24 as well. And then the last one, let's see, times 3 numbers again. This time, let's see, there's 2. 2 times 3, that's 6 again. And then 6 times 4 equals to 24. So these are your 4 solutions, but we're not done yet because even though we have 4 solutions, these solutions can be mixed and matched into different ones. So let's look at the 164. 164, let's see. We can do the multiplication principle, which basically states that we have 3 boxes and we have 3 choices to fill in for the first one, 1, 6, and 4. So basically there are 3 combinations for the first one. And then for the second box, we have 2 because we already chose one from the 3 different numbers. So therefore we have 2. And then for the last one, obviously there's only 1. So for the first one, there are 6 choices. Second one follows the same pattern since these are different numbers again. So 3 times 2 times 1 equals to 6 choices. The third one, this time we need to be careful because there are 2 of the same numbers, both 2s. So therefore, there's only basically 2 choices that we can do for the first one. Let me write this out for us. 226. That is one solution. 262, that's another solution. And finally, 622. So there are basically only 3 choices here. We can list them out since it's only 3. And then the last one, there are 6 choices again because these are different numbers. So 3 times 2 times 1 equals to 6 choices. And then 6 choices, 6 plus 6 plus 6 plus 3 equals to 21 choices. And that's how you do problem 7. Okay, moving on. How many ones between 1 and 1,000? For this one, we can split it into different steps. Number 1. There is only one one from 1 to 9. So basically 1-digit integers. Number 2, there are 11 ones from 10 to 19. And finally, there are 8 ones from 20 to 99. Hence, there are going to be 1 plus 11 plus 8 ones from 1 to 99. So accordingly, there are 20 ones from x, which is just a placeholder, x00 to x99, which is also a placeholder. If the hundredths digit is digit x is not equal to 1, and there are 120 ones from 100 to 199, and also 1,000 has 1. So the total would just be 20 ones from here times 9 So that would give us 180 plus 120, which gives us 300, since the 120 comes from the 121s, from 100 to 199. And finally, plus 1 from the 1,000 gives us 301. So 301 ones from 1 to 1,000. And that is all.